What kind of problems do you have?
Let's see. So now, I get the basics for the most part. It's just like applying it. So let's see.
Okay. Vectors can definitely be challenging. They give, I would say that it's not my favorite subject in math.
Yeah.
What do you got?
So like just the first problem says given BA as a vector equals 2, -3. And BC equals -3, 1. Find AC.
Okay, let's draw a picture. Let's assume that's A. Assume that's C. So AC is not the addition of the two vectors. What is it?
Wait, it's
It's the subtraction of the two vectors. Let me redraw this so that it's a little more understandable here. Okay, if I put B at the origin, and I go 2 over and 3 down, I'm right there.
Yeah.
Now, if I was going to add another vector, I would do tip to tail, right?
Yeah.
Okay, but I'm not. In other words, if I was going to start here and go elsewhere, I would be adding. But I've got a new vector, BC, that I go over 3 and up 1, putting it right there. So this is B, this is A, this is C. And they want to know AC. What do I have to do to get from A to C?
So you have to subtract the absolute value or the answer to
Each component. Well, let's look at AC. What do I have to do on the X to get to C?
To get
-5. I got to. In other words, I got to go 2 units over to the left plus another 3 units. Okay. So AC has to go 5 units to the left. Well, how do I get 5 minus 5? It's -3 minus 2. How far up do I have to go?
That would be up 4.
Right? And I get that by doing that minus that. So AC is the subtraction of the two vectors, but it's BC minus BA.
Okay. So wait, once you have the points, you have to do like the Pythagorean theorem?
No? It's vectors are all about the components. Okay? If my first vector is 2 comma minus 3, it's 2 units to the right on the x-axis and 3 units down. That's how I got to A. That's the vector, BA. Okay? The vector BC is 3 units to the left on the x-axis, 1 unit up. So that's how I got there. That's vector BC. You with me?
Yeah.
Okay. To get from vector A, which is 2 comma minus 3, this point, to this point C, which is minus 3 comma 1, well, how do I get from A to C? I got to go 2 units to the left plus another 3 units. So I got to go 5 units to the left. And I got to go 3 units up plus another 1. I got to go 4 units up.
Okay, but that, okay, yeah, that makes sense.
Okay,
So
so
like,
visually it makes sense.
yeah.
Algebraically, it's a subtraction. When I have 2 vectors starting from the same point, they're both starting from B, and I want to know how far it is between these 2 points, I'm going to subtract my 2 vectors.
Okay.
And I'm going to do it opposite to these things.
Okay.
In other words, to get AC, I'm actually going to take BC minus BA.
Wait, and how do you know that it's BC minus BA? Like, I understand from the picture, but not...
Well, perhaps that will be elucidated for us with another problem. At this point, it's only the picture that allows me to figure that out.
Okay.
In other words, AC is which vector? It's this vector right here, right?
Mm-hmm.
So I can tell that I got to go to the left and up.
Yeah.
So it's not BA minus BC. That would give me a vector of 5 comma minus 4 if I did it in reverse.
Mm-hmm.
Well, this would be vector CA, but not vector AC. Vector AC is the reverse of the signs. Now, how do I know that I got to do BC minus BA? Well, at this point, I looked at the picture.
Yeah. Okay.
Maybe we'll figure out algebraically how to do it on a different problem. We might see a pattern and we can apply it always. But the safest way is to make sure you have a picture and you're going the right direction.
Okay.
What else?
Let's see.
Now, before we go by vectors, it's important to notice that this vector, I always am going to start at the origin. With vectors, it's important to realize something. That vector is identical to that vector.
Yeah.
So if this vector goes to that point there, from 0, 0 to 2, comma 2, that's the same thing as this vector going from 1, comma 7 to 3, comma 9.
Yeah.
In other words, you can take any vector and convert it to a vector with 1 point at the origin.
Okay.
By merely subtracting the 2 endpoints of the vector. Notice that if I subtract the 2 endpoints of this vector, I get 2, comma 2. And it's the same vector as that. And that's a fairly important concept when talking about vectors, is being able to come up with the component form of the vector, which means one side starts at the origin.
Okay.
Okay? All right, what's the next problem you got?
Let's see. one is, okay, this one says given M, oh, this goes into like the 3D one or whatever. So it says given M, 4, -2, -1. And then N, -1, 2, and 0. It says find the positive vector of M relative to N.
which is a subtraction process.
Wait, how do you know that? Like, I don't get what the questions really mean.
Okay. The question says, what is M relative to N, right?
It says, yeah, find the positive vector of M relative to N.
So, vector Mn. The x component. What do I have to do to get from M to N?
Okay.
What do I have to do?
You have well, you subtracted, I guess?
Yeah. In other words, to get from 4 to -1, I got to go 5 units to the left.
Okay.
How do I get from -2 to +2?
4.
Up 4, positive 4. How do I get from -1 to 0?
Up 1.
Believe that's your answer.
Okay. So then, how about when it asks, like, the distance between M and N?
That is applying the distance formula in 3 dimensions. Let's talk about the distance formula in 2 dimensions. I have a point there and a point there. This point is 1, let's say 8, 1. And this point is 2, 3. How do I get the distance between those 2 points? What's the distance formula? Think Pythagorean theorem.
So, wait. B squared?
It's the difference of the x component squared plus the difference of the y component squared, the square root of that whole thing. The difference between 8 and 2 is 6. The difference between 3 and 1 is 2, and I don't care if it's negative or positive because I'm going to square it. So the distance is the square root of 40. You with me?
I think so, yeah.
Okay. Well, when you go to 3 dimensions, it doesn't really change anything. It's the difference in the x components squared plus the difference in the y components squared plus the difference in the z components squared. So what does that give us? What's the difference in the x components squared? It's the difference between 4 and -1.
5.
Squared is 25. What's the difference in the y components squared?
16.
And the difference in the z components squared?
1. Yeah.
Square root of 42 is the distance between M and N. Still there?
Yeah.
Oh, that's because we're on the phone. Yeah, I just got
Yeah.
a message. I just got a message on my GoToMeeting saying you've lost your audio connection. Maybe that's why we were having trouble with it. I don't know. It may not have been your microphone on your end.
Yeah, I don't know.
So, all right. What else you got? Ooh, in fact, I think the audio just came on GoToMeeting.
Oh, wait, it did?
I'll bet it did. Hold on one moment. I don't want to hang this up because then I'd have to call back. We probably have dual audio. Yeah, because I don't hear that beeping anymore. When we're using audio through GoToMeeting, I don't hear that beeping, and I don't hear it right now. But I can't tell because we're using audio through both. But I'm betting that I could hang up the phone right now and I would still be able to hear you. I guess, I don't know. Say something? No, I'm not hearing. My speakers aren't going off when you talk. So, no, the GoToMeeting audio still is not working. So, all right, what else you got?
Let's see this one.
Got a few minutes left.
Oh, okay. So this says find T given that these vectors are perpendicular.
Okay.
And it says R equals T plus 2. Or like T comma T plus 2.
Like that?
Or it's T plus 2 for the second one. So it's like T, and then the second one, T plus 2.
Okay. Okay.
And then it says S equals 3, negative 4.
For these two vectors to be perpendicular to one another, what has to be true? Perpendicular is the same meaning as orthogonal. And a lot of times when you're talking about vectors, they use the word orthogonal. Means they're perpendicular. But
so they multiply to equal 0?
the dot product has to be 0.
Okay.
Okay? And you get the dot product of two vectors by multiplying the components and adding them. In other words, the dot product of R dot S is equal to 3 times T plus minus 4 times T plus 2. So that would be plus a minus 4T minus 8. So what does that give us? That gives us a minus T minus 8. That has to be 0. What does T have to be?
8?
No?
Or negative 8?
Negative 8. In other words, if you solve this equation for T, you get negative 8. And that's the answer. So T is negative 8. So the R vector is actually equal to negative 8 comma negative 6.
Yeah.
And then that vector would be orthogonal to this vector because the dot product is equal to 0. We got time for another short one, if you like.
Let's see. Well, I guess just like another one of those first problems.
One of the most, let me give you a problem just because we only have a couple minutes here.
Okay.
One of the most important things you can do with a vector is to break it into its components. If I have a vector like that goes to this point, and we'll call this point square root of 3 comma 1. Okay?
Yeah.
This happens to be a 30-degree angle, where this side is clearly 1, this side is clearly square root of 3, that side is 2. I constructed it like that, but it's that vector, right?
Mm-hmm.
If you were to break this up into its components, you would want to know what the vertical and the horizontal are. In other words, breaking this vector up into its components would be going up 1 and over to the right by square root of 3. As an example, let's say you have a force. Let's say you have a truck pulling something, a big truck on 4 wheels, okay? And it's pulling whatever, a chain, with a force of 10 pounds. Okay? You with me?
Yeah.
What would be very useful to know is what is the vertical force on that and what's the horizontal force. In other words, if I had 2 trucks, if I had a truck up here pulling on this chain with 5 pounds of pressure, and another truck down here pulling horizontally on that chain with 5 root 3 pounds of pressure, that's the equivalent situation. And that's what vectors are all about. In other words, if I have a vector, if I have a truck pulling at a 30-degree angle on that, that's the same, at 10 pounds, that's the same as the 2 trucks, one pulling north at 5 pounds and one pulling due east at 5 root 3 pounds. That produces the same exact effect on that chain. And how I got that was by taking this triangle and figuring out what its x component and its y component was. In other words, I know that if I have a triangle like this, whose hypotenuse is 10, that's the force vector, then the sides of this triangle have to be 2 and 2 root 3, based on my 30-60 right triangle. Oh, excuse me, hold on. I got that wrong. This is 5, and this is 5 root 3. In other words, I took my 30-60 triangle that had a hypotenuse of 10, and I know that if the hypotenuse is 10, then this side has to be half of that, and this side here has to be 5 root 3. So my vertical component is 5, my horizontal component is 5 root 3. And the way most vector problems are solved, let's say you have a football, a rugby ball laying on the ground, and you have 3 people tugging on it. You have one person tugging in that direction, you have one person tugging in this direction, and you have one person tugging in that direction. And this person's tugging with 20 pounds of force, this person's tugging with 30, and this person's tugging with 40. If the ball is stationary, it means all 3 vectors are canceling, balancing one another out, right? If one of these forces was greater, the ball would move. In other words, if this force was 80 pounds, well, clearly the ball is going to move to the right, correct?
Yeah.
I got 80 and 20 going to the right. I got 40 going to the left. The way I would determine it would be to figure out, well, if I know this angle, then I can figure out the horizontal component of that and the vertical component of that. I can do that for all 3 vectors, add all of the horizontal components together, add all of the vertical components together, and that's the net result vector you get.
Okay.
So, if I said to you, I've got 3 trucks pulling on whatever's in there, a rock, whatever, and I got 3 trucks pulling in those 3 directions, what's the net effect on that rock? Well, I'd have to go through the math and I'd have to know all these angles, but the net effect might be a vector going in that direction with a force of maybe 30 pounds. And the way I would get that is I would break each of these first 3 vectors into their x and y components, and then add all 3 exponents together, all 3 y components together, to get a net x component and a net y component, put it back into a vector to get this. And that's the biggest concept on doing vector problems that you can have. In other words, regardless of the problems they give you, it's usually figuring out what a net vector is given a couple of other vectors. Whether you have an airplane flying in that direction and you have wind going in that direction. To figure out where the airplane's going to go, in other words, let's say you have that problem. You got an airplane going at 500 miles in that direction and you got a 40-mile-an-hour wind going in that direction. Well, what's the airplane going to do? Well, clearly the airplane's going to be slanted a little bit this way, right?
Mm-hmm.
To figure out exactly what the resultant vector would be, I merely take this original vector, break it up into its x and y components, its horizontal and vertical, subtract the horizontal component from 40, that's going to be the net horizontal movement, and whatever the net vertical movement was, that's the net vertical movement. So I can come up with a net vector that I'll know the plane is going 472 miles per hour at a little different angle. It's going a little bit more north.
Yeah.
All vector problems are that. You break up each vector into its components, you add the components, you come up with a new resultant vector.
Okay.
Okay? All right, Sarah.
Thank you.
You're welcome. I'll talk to you next time.